All right, let's take a look at today's lesson. So what we're going to do is we're going to work some more with derivatives. We're going to look at higher order derivatives, which basically means more than a first derivative. That's what those words mean. Higher order means like second derivative and third derivative and so forth. So the notation for higher order derivatives we wrote right here. So I think we've talked about these before, y prime, f prime, dy dx. That's what those look like for the first derivative. For the second derivative, these two notations are pretty straightforward. You just put, instead of one little, prime, you put two. It's fairly easy. This notation is confusing to students. So let me explain why the twos are where they are, right? So this two means the second derivative. This two means with respect to, that's an abbreviation, WRT, with respect to x for the second time. So that's why those twos are where they are. The top two, the one in the numerator, is by the d because it's declaring this is the second derivative. And the bottom two is by the x because it's also declaring it's with respect to x for the second time. Does that make sense? That's why those twos are where they are, because that tends to be confusing. With the third derivative, we have three little, prime marks. That's pretty easy. And again, we've got this location where the threes are, and it's the same reasoning where the twos were. It's exactly, the top three is by the d because it's the third derivative of y. And the bottom three is by x because we've taken it with respect to x 3 times. Now that seems like silly that we would write that, but as we go farther in calculus and do multivariable calculus, there are derivatives that are called, they're derivatives with different variables in it. We aren't going to do that kind except for implicit differentiation. So I'm just saying there's a reason why they put for x the second time. There's a reason for it. And for us, it's just, pretty straightforward. So questions on notation. All right, so what I'd like to do, we're going to actually find the second derivative. We've got two different examples where we're just going to do the equations. We're just going to work through finding the second derivative from our equations. So what I would like to do first off is I would like to rewrite this one. Square root of x, we don't really do derivatives in radical form. We change it to be exponential form. So I'm just going to rewrite it as x to the 1/2 plus x to the -2. Okay, so now we're going to find the first derivative. So I'm going to use the y prime kind of notation for this example. So y prime, we're just doing power rules. So I do 1/2 x to the -1/2. Okay, that's the power rule for x to the 1/2. For the next one, I bring down the -2, and then I subtract 1 from -2, and I get -3. And that is my first derivative. Now, it does have negative exponents, just like this did. And if that bothers you, you can change it, but I would recommend that you don't change it until we're done taking derivatives. Okay, so we need one more. So y double prime. Now, the way to find a second derivative is to simply take the derivative of the first derivative. That's what we do. To get a second derivative, we have to have already found the first derivative or been giving it, and then we take the derivative of it. That's all. So now let's do the derivative again. We're going to use a power rule. So 1/2 times -1/2 is -1/4 x to the, I'm going to subtract 1, so that gives me -3/2. So I've finished with the first term. So the next one, I would bring down the -3. So -2 times -3 is a +6. And -3 minus 1 is -4. Now, I am perfectly fine if you leave it like this for me. That's fine. If it were multiple choice, it probably would not look like this. So I'm going to rewrite it with no negative exponents. Again, I'm okay if you leave it like that. But let's go ahead and rewrite it so you can see what it looks like with, without negative exponents. And they would probably put the radical back. See how they put a radical in the question? They would probably put a radical in the answer also. So we would do negative 1 over 4 times the square root of x cubed plus 6 over x to the fourth. So that is another way that you could write it. Again, it's if you want to, or if you're trying to match your answer to a multiple choice answer. That's typically why we would want to rewrite, is just to match a multiple choice answer. Okay, questions on this one? All right.
What happens to the negative for the
negative 3 over 2? Oh, this little guy right here? This one? So I kind of skipped a step. Let me move it out here. So if this would be like negative 1/4 times 1 over x to the 3/2. Right? Remember, a negative exponent, if it's in the numerator, I could push it to the denominator and it becomes positive.
Okay.
So that's why that's down there. And then I changed this into a radical. Remember is that okay?
Yeah.
Okay. Any other questions? Okay, the next one is a mixture of x's and y's. What technique do we use when we have a mixture of x's and y's? Implicit differentiation, remember that? We did that a little bit ago. We've got to use implicit differentiation. They want us to find the second derivative. Okay, so let's do the first one. So the derivative of sine is cosine. Copy paste the y, and it's a y. So I take the derivative of y, and it's 1 dy dx. I actually recommend that you just always chain, no matter what. Even if the chain is 1, then you won't forget. That's one of the most common things that we forget, is chaining. Just chain everything. So I would think of this as is the outside, and this is the inside. So the derivative of sine is cosine. Copy paste the inside. The derivative of y is 1 dy dx. Okay, equals. The derivative of x is 1. The derivative of y is 1 dy dx. Okay, so let's think back to our implicit differentiation work. Recall that we get the dy dx is on one side, right? I'm going to move dy dx to the left. So we have cosine y dy dx minus dy dx equals 1. Then recall what we do next. We factor out the dy dx. Very good. And then our last step is to solve for dy dx. So I'm going to divide both sides by cosine y minus 1. So dy dx is 1 over cosine y minus 1. And that's great. I'm going to go ahead and just box this in so that we have this as a reference, because we'll need it in a little bit. That's my first derivative. It wants me to find the second derivative. I would recommend, now I don't want to hurt the quotient rule's feelings. I mean, I know it's a quotient rule, but if I can get away with not doing the quotient rule, that's what I'm going to do. So I would take that bottom cosine y minus 1 and pull it up to the top and make it to the negative 1 power. You with me? So that it would make my life easier. That's what I would do. So I'm going to just rewrite this to be cosine y minus 1 to the negative 1. Okay, that's just going to make my life easier. That's the only reason I did that. All right, so here we go. So we've got d2y over dx2 equals. I'm using that kind of notation. Do you have to? No. I'm just telling you it would be helpful if you did with things like this. So now we're going to do a power rule, actually a chain, a power chain. I'm going to bring the negative 1 down. I'm going to copy paste the inside cosine y minus 1. I subtract 1. Negative 1 minus 1 is negative 2. Then what do? I did the outside, so we can, if we'd like to, I can put this. So this is the outside, right? We did that derivative. Then I've got this one. And then I have this one. Right? I've got 3. And maybe that's hard to see. So I have the outside one, which is to the negative 1. I've got cosine of y minus 1, and then I've got this. Okay, so the derivative of cosine y, the derivative of cosine is negative sine. Copy paste the y. The derivative of y is dy dx. The derivative of negative 1 is 0. Okay, so that's the middle. And I actually changed this already. This is that. Okay, are we okay? All right, so now you might think, oh, great, we're done. No, we're not done. I know, darn. It's really not okay to have a second derivative symbol and a first derivative symbol in your answer. That's really not okay. You with me? It's not okay. So what do we have to do? Well, what we have to do is we've got to take this right here, and we're going to have to replace it with this. I mean, that's what we have to do. We have to replace the dy dx with dy dx. We're not allowed to leave it there. That's not okay. Okay, so I'm going to work through this fairly slowly. This is, now we've done the calculus, now we're just doing algebra, right? Isn't that the hardest part of calculus is algebra? So we're doing the algebra now. Okay, so I'm going to write d2y over dx2 equals. So that first one, I'm just going to rewrite as 1 over cosine y minus 1 squared. Okay, I'm just going to rewrite, that's this first piece. I'm just rewriting it. The second piece is negative sine y times, I've got my 1 over cosine y minus 1. I had to stick the dy dx in there. So I'm going to pause here for a second. We all okay? All right, so the last thing we're going to do is just again, it's just algebra. We're cleaning up the algebra. So d2y over dx2 equals, so negative times negative is positive. 1 times sine y is sine y over. These two are the same, right? Cosine y minus 1, cosine y minus 1. That's to the second power, that's to the first. So remember our exponent rules. Can't I bring these together, right? And make that to the third? Yes, I can. And that is my final answer. Okay, so I'm going to pause here for just a moment. How are we doing? So I will just say that as second derivatives go, implicit differentiation for second derivatives is the hardest thing. I'm not going to lie. If you found that hard, it's because that's the hardest thing, is doing second derivatives implicitly. It's just harder. It's harder than, because why? Because we got to plug back into it. We always do. We always have to get rid of that part right there. Okay. Now we have 2 FRQs to do. The first one is calculator. Okay, the first one is calculator. So if you want to work along with your calculator, you certainly can. You don't have to. Okay, so let's look at the first one. Okay, so here we go. This is number 3. Let's look at the prompt. I guess I need to shrink it. Sorry, it's so small. You'll have that on your computer. You can see that. So we've got a table right here. We've got a table that we need to pay attention to. You know, these have G's. We just need to pay attention to You know, this is G's. Okay, we'll get to that in a minute. Then we've got this, it tells us that G is differentiable and decreasing. So that's just telling us what's in the table. Then they're giving us another function, and they give us this value, which we should pay attention to. They generally don't give us values for no reason. They generally don't. So if they're telling you something, you're going to probably use it. So just highlight it, do something with it. And then they give us f prime, which is actually weird looking, which is why, you know, we're going to have a calculator, because that's too much going on right there for finding the derivative of that and putting numbers in it. Okay, so now we know what we have. We've got G and G prime have data points in the table, and f prime is an equation. Okay? So it asks us to find f double prime of sine x. Now, please do not try to do that by hand. That is a terrible idea. You have a calculator. This is our little calculator symbol. We're going to use it. What do I need to show as my work? I'm going to say f double prime of x at sine 2 is. That's my work. That's all you need to show. F double prime of x at sine 2 equals. Okay? So I'm going to pull up my calculator. Are we good? Okay, so I'll pull up my calculator. I actually, come back, little calculator. I don't know. It's being shy. Come on. Well, I don't even know. Oh, here we go. All right, so now we have our lovely calculator up. So what I'm going to do is I'm going to actually add a graphing page. I'm going to store that equation in my grapher. And the equation was what? X. And I would highly recommend that you do the times there. I don't know, the calculator can be fussy whether it recognizes it or not. So just put the times there. We're going to do cosine of e to the x. So of e to the x. Okay, so make sure you're in radians, because it's going to do crazy stuff if you're not in radians. And then I'm just going to store it. I'm going to hit enter. And now that is a weird graph, don't you think? That is weird. I mean, we don't need to graph it. I'm just storing it there. What I want to do, I'm going to do another page. So control doc. So I'm going to add a calculator page. And I'm going to find the second, so I'm going to do the derivative of the derivative. What I put in there was the derivative. So we're going to do, the way that I get to that page is I do menu, calculus, derivative at a point. My variable is x. The value is sine of 2. So we're going to do sine of 2. Okay, we're going to keep tabbing, so that's okay. Now I'm going to remember how we do that, where we hit where we stored it with the var. So f of 1, f1 or whatever. There is my, it's going to calculate it for me. Now, you know the calculator's weird. I really just want to hit enter, but what's it going to do if I hit enter? It's going to give me weird stuff, right? Like with variables and like sine in it. So question.
So just to be clear, like the f prime equation is x cosine of e to the x, and the value you want to find for the x in that equation is sine 2.
Yeah. Well, what I want is to find the derivative of, I have the first derivative.
When x is sine 2.
I want to find, yes, the second derivative of it when x is sine 2. Okay. That's what I'm trying to do. And so I'm going to hit control enter so that I just get a normal kind of number instead of the crazy stuff it would give me. And that's my answer. And I just copy it down. There's no there's no handwork to do. Please don't try that. It will not go well. All right, so we get our answer of negative 2.1728. I'm just going to put 4 decimal places instead of 3 just because I don't want to worry about rounding or truncating. You can round or truncate if you want to. If you round, you would get a 3 there, right? If you truncate, it would be a 2. But why worry about it? Just leave it like that. Okay? And that we were given the first derivative, and I found the second derivative by using my calculator. Okay, are we okay? So that's just pure calculator work. All right, let's see what they want us to do in part B. Part B, they say, let h be the function defined by just that weird mess of stuff. Find h prime of 1.5. Okay, that looks a little overwhelming, but I'm just going to back up and I'm going to say, oh, well, to find h prime, I need to actually take this and find h prime. We have to do that by hand. That's not something we can tell the calculator to do. So, because, g is just a bunch of individual numbers. It's not an actual equation. All right, so we're going to do that. So h prime of x, this is composite, right? So we're going to have to use what rule? Our chain rule, right? So let's just kind of do our boxes. So what do we got going on? We got this outside part, we have the middle part, and we have the inside part. I've got 3 chains. There's 3. Okay, so let's do that. So h prime is going to be, so the derivative of g would be g prime, copy paste the inside, don't even look at it, times, I'm going to go to the middle function. The derivative of f is f prime, copy paste the inside, don't look at it, times. I'm going to go, I keep referring to this over and over again, right? I go back here to figure out what I'm doing. Now I'm going to take the derivative of the innermost function, which is 2x, and the derivative of 2x is 2. That's my derivative, as bizarre as it looks. That's it. Okay, now they want me to find h prime of 1.5. Okay, fine. So what am I going to do? I'm going to put a 1.5 everywhere there is an x. G prime of f of, so 1.5 times 2, it would be to my advantage to go ahead and do that. Do we know 1.5 times 2 would be what? 3 halves times 2 would be 3. Okay, you have a calculator. If that doesn't make sense, you could put it in a calculator. Times f prime of, again, 2 times 1.5 or 2 times 3 halves is 3, and then times 2. Okay, is everybody okay? All right, so what we want to do now is we want to identify what f of 3 is so that we can figure out g, because we don't know what's going on with g. So f of 3, so what would I do? I'm going to, this is hidden over here. Look at there. There's f of 3. See how they wedged it up there? If you don't circle it and pay attention to it, you would probably be going, oh my gosh, I don't know what f is. I know what f prime is, but I don't know what f is. Well, they told us. It's right there. All right, so f of 3 is 2. So we've got h prime of 1.5 equals g prime of 2 times f prime of 3 times 2. All right, well, the g prime of 2, remember g is in the table over here. So let's get this table. So g prime of 2, so there's a g prime, here's the 2. So g prime of 2 is negative 3. So negative 3 goes right there. Okay, I got it right out of the table. Where am I going to get f prime of 3 from? I'm getting from the equation, right? So it's going to be 3 times cosine of e to the 3. I'm just going to put it like that. I'm not going to worry about my calculator right now. Times 2. In fact, I'm going to just leave my answer like this. So h prime of 1.5 is, I'm just going to call it, let's see, 3 times 3 times 2. Let's see, 9 times 2. So negative 18 cosine of e cubed. I'm going to leave it like that, and they're fine with that. Now, if that really troubles you and you don't want to leave it like that, you can put all of this in your calculator, and you're going to get approximately negative 5.915. Now, it does say it wants us to enter it as a decimal approximation, so I suppose we have to put it like this. I guess they're making us do it. Darn. Express your answer as a decimal approximation. I really wanted to leave it like that because that's way easier. And I don't have to mess with a calculator. But they didn't let me, so okay, that's fine. H prime of 1.5 is about that. Okay, are we okay? Okay, let's look at part C. Everybody good? All right, let's go to part C. Write an equation for the line tangent to the graph. Oh, our favorite inverse. Oh, does it bring back nightmares? I know, that was a crazy lesson, right? Yes, but we've got this. We're going to make us do it over and over again. Over and over. Okay. Write an equation for the line tangent. Okay, we good? Of g negative 1, the inverse of g at x equals 2. Okay. Well, let's figure out what's going on. So let's remember about the relationship between the inverse and their function. The x and the y's are switched, right? So this equation of line tangent, this is the x value for g negative 1, right? That's the x value for g negative 1. So it's the y value for g. We should just write it out since it's confusing. Just write it down. That's the x value for g negative 1 is the y value for g. So let's look, g is in the table. Let's look at our table.
Wait, so you know that from the last lesson, using that same logic?
That's correct. That's correct. And we know the relationship between inverses because of pre-cal, right? We learned that inverses, we switch the x and the y. Okay, so the y value for g is negative 2. So I need to look up here and find, and notice how they love writing negative 2's everywhere. Here's my y value of negative 2. See that? It says the y value for g is negative 2. Okay, so what does that mean? That means that g of 3 is negative 2. That's what it means, because g negative 1 of negative 2 is 3, right? They just flip. The x's and the y's flip. Okay, so yes, I hate to put it, I mean, we have to remember the formula. We've got to find the derivative. Okay, so let's remember the derivative is the formula, 1 over, and we're using g and g's, 1 over g of g negative 1 of x. That's the formula for the derivative. So this is for the derivative of g negative 1 of x. That's what this is. Equals. Okay, that's what we're doing. That's the formula. So, okay, g negative 1 of x. See this right here? G negative 1 of x. What is g negative 1 of x? It's 3, right? So 1 over g of, and I can write it out if it's really troubling us, g negative 1 of negative 2 is 1 over g of 3, excuse me, g prime, those are primes, g prime. How am I going to find g prime of 3? The chart. I'm going to go to the chart. So that's going to be 1 over, let's see, g prime of 3, g prime of 3 is negative 4. So that's my slope. That's my slope. I'm just going to write, well, that's my slope. We want the equation for the tangent line, which means y minus y1 equals m times x minus x1. That's what it means. So y minus, I'm not sure, equals negative 1/4 times x plus 2, right? Because that's my x value. What's my y value? Do we already know it? We do, don't we? G negative 1, the inverse, G inverse of negative 2 is 3. And we're done.
Why did you keep the 3 in the top? The 3 times 1.
In the table.
Oh.
In the table. So this is negative 2, this is the y value for G, right? So I found the y value for G, it's right here. This is negative 2, and that means it matches to 3. So that's the regular function, and that's the inverse function. Is that okay? Okay. One more on this one. I would say between the two FRQs, this one is the hardest one. Usually the calculator ones are the harder ones. And you might be thinking, yay, let's have a calculator one. And I'm thinking, no, you have no idea what you're asking for. No, don't ask for the calculator. That's okay. Here we go. Last problem on the calculator one. Let H, well, no, we have let's see, where are we? The point 3,1 lies on the curve in the xy plane given by the equation of, oh, they gave us another equation, yippee. What is the value of dy dx at 3,1? Okay, another decimal approximation. Okay, so we've got to do the derivative. So what am I doing? I'm taking, and I'm just going to write up here, just maybe save some time, or maybe it won't, I don't know. So we're going to do the derivative of this side, and we're going to do the derivative of this side. That's what we're doing. Okay, because that's what it wants us to do. The derivative. Okay. So the derivative of f of x squared would be a power rule. 2 times f of x to the first times, right, it's chain, times f prime of x. So let me do the little markings if that's helpful. I don't know if it is or not. I've got the outside one, and I've got the inside one. That was a chain. Here's the outside one, and there's the inside one. Okay? Plus, the derivative of g is g prime, equals. Oh, look at our little innocent looking xy. Look at that. Doesn't it look innocent? We know it's not, because it's what? Product rule. It's product rule. I know, it's like, oh my goodness. That, again, I told y'all that's why I have a product rule stamp, is because of that little guy. I do. XY is just, oh, it drives students crazy. So remember the product rule. FG plus FG, first things first, second things second. Okay, so the derivative of x is 1, copy paste the y, plus. Copy paste the x, the derivative of y is 1 dy dx. The derivative of 1 is 0. Okay, this is all right. We're supposed to plug in this value. That's my x and that's my y. Okay, let's plug it in. So 2f of 3 times f prime of 3 plus g prime of 3 equals 1 plus 3 dy dx. And by the way, what we're looking for is dy dx. That's what we're looking for. I'm not solving for it yet because that's just too hard. I'm going to do all the numbers first and then I'm going to solve for it because that's a lot going on. So f of 3, what do you think f of 3 is? Bless you. Guess what? There it is again, f of 3. They've used it again. Our little friend, f of 3 is 2. So 2 times 2, f prime of 3. Well, I'm just going to stick a 3 in my, so it'd be 3 times cosine e to the 3. That's f prime of 3. Plus, where am I going to get g prime of 3 from? The table. G prime of 3, we go to the table. G prime of 3 is negative 4. equals 1 plus 3 dy dx. Now, the rest of it is calculator. I'm just going to say you would use your calculator to, add these things together, subtract the 1, and then divide by 3, right? Algebra. It's all algebra. And then you would get dy dx equals negative 0.352. Phew. And let's leave the calculator behind. What do you think? Let's leave it behind. We have one more problem. Are we okay?
Is there a calculator on the test?
I don't know. Good question. I do not know. Okay. Y'all okay if I don't put one on the test? I know, right? But be careful what you ask for, right? Don't ask for a calculator question. I'm just saying. All right, here we go. Here, it's a similar question, but we don't have a calculator, so it's not going to be as intense, to be honest. It's not going to be all that crazy. We are given the first derivative, and we're given this. So you might take notes. I don't know if you want to highlight it, what you want to do. We're probably going to use it at some point. Just be aware it's there. So they want us to find the second derivative at negative 2. Well, we have the first derivative. We know how to find the second derivative, right? Second derivative of x. So here we go. Sine of pi x, that's a chain. Here's my, outside, and here's my inside. Okay, so the derivative of sine is cosine, copy paste the inside, times the derivative of the inside. What's the derivative of pi x? Pi, right? What's the derivative of 3x? 3. It's the same kind of thing. Okay, plus. The derivative of x squared is 2x, and the derivative of 3 is 0. Okay, that's not too bad. So now we just need to stick a negative 2 in there, and then we're good to go. So cosine of negative 2 pi times pi plus 2 times negative 2. And you see why we have to know unit circle values? Right? We need to know what cosine of negative 2 pi is. Do we know what it is? It's 1. So I have 1 times pi minus 4. So f double prime of negative 2 is pi minus 4, and we're done. Okay? Is everybody all right? Yes? Okay, I'll pause for just a moment, just make sure we're all together. Okay, here we go. So now we're going to write an equation for the line tangent to the graph. Y equals 1 over f of x. What do I need for a tangent line? Y minus y1 equals m times x minus x1. I mean, that's what I need. That's what I need. So I need to find, I know what this is, right? That's 0. Okay, got that. Y is going to be, y1 is going to be 1 over f of 0. So do we know f of 0? Look at there. We sure do. They snuck it up there. F of 0 is 2. So it's 1/2. Okay, wonderful. We've got that number and that number. All we lack is the slope. How do I find the slope? The derivative. I'm going to have to take the derivative of this. I would recommend that you rewrite it so it is y equals f of x all to the negative 1 so that you don't have to do quotient rule. That's just a recommendation. If you like quotient rule, go for it. Okay? I'm not going to use quotient rule. I'm going to use this power chain business. So y prime would be bring the negative 1 down, copy the inside to the negative 2 times the derivative of the inside. Okay, I'll just do that again. So this, remember, it's a chain. It's this part is the outside. This part is the inside. Okay, I need y prime of 0. So negative 1 times f of 0 to the negative 2 times f prime of 0. We know what f of 0 is, right? Didn't they tell it to us? F of 0 is 2. So y prime of 0 is negative 1 times 2 to the negative 2. And f prime of 0 means we put a 0 up here. What's sine of 0? 0. And 0 squared is 0 plus 3. So f prime of 0 is 3. Okay. What does this negative 2 mean? What am I supposed to do with that? Yep, I'll just make it a fraction. So this is basically negative 1 times 1 over 2 squared times 3, right? Which is what, negative 3/4? So our tangent line, y minus 1/2 equals negative 3/4 times x minus 0. I recommend you leave it alone and don't try to distribute and combine like terms. Just let it be. Okay, how we doing? I'm going to pause here for a moment, make sure we all get caught up. Okay, ready to keep moving? You're like, how much more do we have? We have 2 parts left. I told you this was going to be a lot. FRQs take a long time, but I think you would rather have this to go by, right? You would rather go through one, at least go through one. All right, so G prime. G prime of x equals. This is definitely a chain. We're going to pull it apart. So this is the outside part, right? F. This is the inside part. You know, and then this is the inside part. Okay. So f prime of, copy all that stuff. Just copy it down. Don't look at it. Don't let it freak you out. Times. The derivative of, it's like that is to the 1/2, right? It's like 3x squared plus 4 is to the 1/2. That's what we're doing the derivative of, the 1/2 part. 1/2, copy paste the inside to the negative 1/2 times. Then the very inside one, the derivative of 3x squared plus 4 is 6x. And they just want the value at 2. They just want the value at 2. So let's just throw the number in there and figure it out. So f prime of square root of, let's see, 2 squared is 4. 4 times 3 is 12. 12 plus 4 is that 16? That's right, isn't it? You all know my arithmetic is terrible. I think that's right, isn't it? Okay, thank you. Times 1/2 times, and that's the same thing. Putting the 2 in there, that's going to be 16 to the negative 1/2 times 6 times 2. Okay. So I think putting the numbers in it made it a bit easier. So we want f prime of 4 times, we know what this is, right? 1 over 2 square root of 16. Right, that negative 1/2 is just where you put that on the bottom, remember, the exponent? Okay, so f prime of 4, where are we going to get that one from? Oh, that's the function up there. Yeah, it's that business. Okay, I have it written on my paper, so I'll just go off after what I wrote on my paper. So f prime is sine of 4 pi, I'm just plugging a 4 in the formula, plus 4 squared plus 3. this is that's f prime of 4. I just plugged that in. And this times, what, 12 over 2 times 4, which of course is simplified. Do we know sine of pi over 4? Excuse me, sine of 4 pi? 0, thankfully. G prime of 2 is going to be, what, 16 plus 3? 16 plus 3 times, that reduces to 3/2, which just arithmetic is 57/2. We're almost there, ladies. We're on the home stretch. One more. Okay. Are we okay? All good? Okay. Last one. Oh, look at our little friend here. They're just killing us with inverses, aren't they? Sorry. It's going to help us, though. We're going to be much better at it. So h is the inverse of f. H is the inverse of f. So h is f negative 1. That's what they're saying. H is f negative 1. They want us to find the derivative of the inverse again. Okay. Well, let's figure out what do we need? We know this is the x value of h, which means it's the y value of f. With me? If that is the x value of the inverse, then it's the y value of the regular function. Okay, so we must know about the y value of the regular function. Looky there. And there it is again, right here, again. Okay, so we know f of 0 is 2. So h of 2 is 0. I mean, that's what we know. Okay, our formula is 1 over f prime, the regular function prime, of the inverse function, and the inverse here is h of 2. So we're supposed to do. H of 2 is 0. 1 over f prime of 0. Okay. What do we know about f prime? It's that equation. 1 over, I'm just going to use the equation, so that would be sine of 0 plus 0 squared plus 3. So h prime of 2 is 1/3.